Hello, good evening. Today is Tuesday, October 20th, around 8:35 p.m. Dallas, USA, Central Daylight Time. And I am doing this recorded video presentation for the SmartBlock conference, which is on blockchain, which is going to be held in China on October 23rd, sometime around I think 9 or 10 o'clock in the morning. So I will be also be present giving this presentation live, and that's going to be Thursday night USA time, I believe around 9:35 p.m. And the talk is scheduled for half an hour. So this is going to be a half an hour presentation. And at the conference, I will, as I said, I'll be present and I'll be giving this talk live, and then I will be there to answer questions. And I'm Bhavani, professor at the University of Texas at Dallas. And thank you very much for inviting me to give this keynote presentation. I am most honored to give this presentation. Thank you. So what I'm going to do now is share my screen. So the time is 8:38. So I will be finishing around, I believe, 10 past 9 US time. So, right, so I'm going to share my screen. Okay, and yes, here's my talk. And my talk is going to be blockchain technologies with applications in data science and cybersecurity. Okay, so blockchain, cybersecurity, data science, or blockchain, data science, cybersecurity. First, I will give some motivation, right? And that is to do with data science and cybersecurity. How do we integrate data science and cybersecurity? In particular, I'll talk about the privacy-aware policy-based data management framework that we have been working on, and then data science for cybersecurity, and cybersecurity for data science, which is adversarial machine learning, and then very briefly talk about the applications in Internet of Transportation Systems, cloud, and social media. So I've given keynote addresses on each of these topics: Internet of Transportation and cloud and social media. So I'm combining everything together into a few charts. And then a brief overview on blockchain technologies, and very briefly how blockchain could be applied to data science and cybersecurity, and then some directions. I do have an associated paper with this keynote address published in the proceedings of the SmartBlock conference. And so you'll be able to read the paper. So the presentation pretty much follows what's in the paper. And so we've done some more in-depth work in the blockchain, in particular as applied to cybersecurity and data science. And that work has been presented last year at the IEEE conference on data mining. Okay, so we know that because of machine learning, data science, AI, data mining, we can collect lots and lots and lots of data together and infer something that is highly private and highly sensitive. So we all now have, almost all of us have our smartphones, Androids, or iPhones or whatever. And this smartphone can get all sorts of information, right? You put the app, you load the app, and then you can get health-related information, fitness data, location data, social media data, images and videos, and other data structures. And so what the smartphone should have, and that's what we are building, is a data collection module, data storage and access module, data analytics, data sharing module, right? And all of these modules together is what we call the data management framework or collection of services. So we call this privacy aware, right? Because it has to provide privacy, but our contribution mainly is policy based. Every step of the way, whether we are doing data collection or data storage or data analytics or data sharing, policies should govern every action. And then there is some encrypted backup storage, some of the data, because you cannot store all of the data in here. So some data goes in here, and some of the data anonymized, encrypted sharing data query results. So it's cloud-based services and cloud storage. But what we are building is the privacy-aware quantified data manager, policy-based. And so when I say policies, we computer scientists, we talk about sort of TOY policies. But that's not what I mean. We are working with real policy experts, right? And they are coming up with policy. These are folks who have got professors who've gotten their PhDs in policy. So we are working with them. So this is the crucial part. Now, every step of the way, policy-based services, data management. So, and this is essentially what we are building. And then we have got the cloud-based encrypted data store for querying and results, and some other store for storing the results. And this is our mobile device. So as more data being collected, storage on the device will not be sufficient to store all of the data. We have envisioned an encrypted cloud storage component where all the data and all less frequently accessed data are pushed to the cloud. Okay, based on the access control policies, the local apps are running on the device will be given access to some of the collected data. When needed, these apps will be allowed to access some of the encrypted data stored in the cloud, some through some query interface. So we don't want to store too much information in our mobile device, right? So if you're 20 years old, we don't need to store the data like the weight every day, right? Or blood pressure every day, because rarely a 20-year-old's blood pressure would be 200 over 150 or something, right? No. But for a 70-year-old, it's different. So we may want to store all of the data. And in other cases, data may have to be deleted to preserve privacy, because there could be fake location data. And one of the things that that concerns me is that we can, based on the illness that we have, our children could be denied coverage. So let's assume that, say, I have diabetes and my son could have a perfectly healthy blood glucose level. But then they might say, oh, his mother has diabetes, so he might have a predisposition for, thank goodness I don't have diabetes, okay? So he might have a predisposition for diabetes, and so they may deny coverage. So these are all very important considerations, privacy considerations. And then we envision data sharing and analytics will be carried out as services. And then based on different scenarios, let's see, we can, some data could be sent without modification, some data could be sent after modification, sanitization. And the main thing is some could be sent in encrypted form. So again, it's policy-based, privacy-aware, and the whole research could be, how do we express the policies? What language do we represent the policies? And what about how do we execute the policies? These are some of the challenges. Now, when you say we want to delete the data, does that mean the data is deleted, right? We don't know, because the data could still be there. So how do you do? I mean, what do you do? There should be policies, auditing policies, right? Auditing to make sure that the cloud has indeed deleted the data. Okay, so that's one aspect. Another aspect that we've been focusing on is data science or machine learning for cybersecurity. So again, we are working with my colleague, Professor Latifa Khan. They're streaming data. Data is coming continuously, right? So it's a continuous flow of data, very common in our connected world. It handles massive amounts of data. So the data comes in, models are built. And again, when that's for the test, sorry, for training. And then concepts are changing. Why are the concepts changing? Because when you have continuous streams of data, right, even say with news stories or whatever, these concepts are going to change. One thing that is important today may not be important tomorrow. And so what happens is that as this data comes in, we are developing several models. And as these models are developed, some of these old models could be outdated, right? So what do? We throw away those old models and then we replace them with some new models. And so that's a continuous process. And there could be human in the loop trying to check. And so this is a continuous evolving models, right? That's the challenge that we are faced with. And then when test data comes in, these models will start working. If it's attacked, then we block and quarantine. If not, then if it's benign, then it goes and stores in the server. So again, the challenge is the model update problem, because the models are continuously changing. Okay, so It's a joint work also with Professor J.W. Han, University of Illinois, Urbana-Champaign. We have published a number of papers. And so data science, without a doubt, is helping cybersecurity. Okay, so, and I'm going to lead up to why I'm talking about this when we talk about blockchain. Okay, so here we applied it to insider threat detection, our data science algorithms. So we have I chunks, they come in, and then, we gather data and extract features. We build an ensemble of models, a collection of models. We apply learning algorithms. We have done supervised learning and unsupervised learning. Unsupervised is graph-based anomaly detection, and supervised is support vector machine. And this is our online learning. And then the I+1 chunk comes in, and that's the testing. And we detect, is it anomaly, extract features, and is it an anomaly? We apply these models, and is it an anomaly or not, right? Insider threat is a very interesting problem because there are people who might really be bad people, but they pretend to be good inside the company. And we look at them, they are highly cleared folks and they are highly reliable, but they are really bad. Similarly, the processes, they could pretend to be good processes, a process that is gathering some statistics, say, or a process that's part of a database process, but they are really malicious process. They're gathering all the information and then sending it to the perpetrator. So that's the insider threat. Okay, so we've applied data science, published a number of papers. One of the most popular areas in cybersecurity, what happens if the machine learning data science techniques are attacked? That could be a disaster, right? Because we have data science machine learning that's being applied to almost every area, whether it be, let's see, any type of, right, healthcare or pharmaceuticals or financial applications or whatever, right? It's being applied everywhere. And what happens if these machine learning techniques are attacked, right? So an adversary is going to watch what we are doing, right? Our models, our data, it's going to poison our data and thwart our models. And we have to understand the adversary, and we have to be several steps ahead, right? So we have to act. It's not concept learning. It's not online learning. Adversaries adapting to avoid being detected during training time by data poisoning, during testing time, modifying the features when data mining is deployed. So it becomes like a game playing between us and the adversary. So you can see here, when we apply support vector machine, this is the support vector machine line. The red squares are bad instances, and the blue circles are good instances. So adversary is trying to push as many of these red squares into this blue area so that we won't catch the bad instances. See what happens now? The red instances, 5 red instances have come below this line. That means we think that they are good instances. Why? They have known what our model, they know our data, and they're slowly trying to maneuver in order to push those squares into our good instance category, right? That's what we want to prevent. So what do? And this is with Dr. Murad Kantajlu. We published a paper in KDD. So this is the support vector machine line. And what we are doing here is moving this support vector machine through studying the adversary's behavior. We want to adapt. And so we want to move this support vector machine to this blue line, artificially move it, but not randomly. I mean, we want to study the adversary. What are the types of attacks? So a lot of considerations. It's not so easy just to move it here. No, it's not for fun of it. We have to be calculating, look at all the parameters, and then move the dashed line to this blue line. And so what happens? A lot of these crosses, right, are now shown as, these are the crosses which are bad instances, red crosses, green circles I'm saying are good instances. And so by having the support vector machine line here, some of these red crosses are not being caught, right? So we think it's good, but no, it's really bad. But by moving this line, then we are catching more of the bad instances. But then you can say, why not move this line here? That means we can catch all the instances. But imagine, if we move this blue line here, all these green circles will also be known as bad instances. We do not want false positives, nor do we want false negatives. Both are bad. And so by moving this, you can see, right, you have a lot of red crosses and green circles, but a lot of this black stuff here, which are really bad stuff, are now being caught because we have moved this line. So a threat model, test time deployment attacks, attacker modifies X to X prime, modify packet length by adding dummy bytes, add good word to spam, add noise to any image. So black dashed line is a standard support vector machine classification boundary, and the blue line is the adversarial, the new support vector machine that has taken into consideration the attacker's behavior. So that's a major contribution. We were one of the early researchers to work on this, but now there are several people working in this area. Okay, so that's machine learning techniques being attacked. Another area, and I'm just going to show this because of lack of time, we've done a lot of work on Internet of Transportation. We all know about Internet of Things, right? Your refrigerator being connected to your mobile devices, being connected to your television, being connected to your computers, whatever. But in the Internet of Transportation world, it's all about transportation systems. So all of these cars are connected to each other. And the train is connected to cars, and the trucks are working together. They are connected. And here are the roadworks. They are connected to the cars. So we have an Internet of Transportation systems. It's not just land vehicles. It could be aerial vehicles. It could also be sea vehicles. And we have come up with techniques for security and privacy, so especially attack detection in AVs, autonomous vehicles. Okay, so that's a major contribution that we made last year. And it doesn't bring in any data science or AI techniques. We have used some, traditional Kalman filter, so extended Kalman filter from control theory, and we have modeled the whole system based on physics-based properties, and then we applied Kalman filter and come up with this technique to detect what is an attack, has the system been attacked or not. So one of the challenges that we are focusing on is, can we bring our AI and data science techniques into this picture? Okay, meaning that can we bring AI and data science to be able to detect these security attacks, right? So we have done something with Kalman filters, but we want to be able to handle more sophisticated attacks. So maybe we should bring in this AI technique. So that's one area of research. Another area of research is the privacy. Remember, we talked about, in our smartphone, we are collecting all kinds of stuff, data collection, data storage, and so on. So now in our autonomous vehicle, there is radar data, GPS data, camera data, LiDAR data, ultrasonic sensor data, and some of the data encrypted, stored in cloud. Some cloud-based services we anonymize and get encrypted query results, shared data. And we call this privacy-aware, policy-based autonomous vehicles. So whether we are collecting data in the vehicle, storing data, analyzing data, sharing data, policies play a major role. So what we are saying is, can we do something like that? Instead of having healthcare data, social media data, and heartbeats and glucose levels and so on, radar, GPS cameras, can we build a system like this inside the autonomous vehicle? So that's another thing that we are focusing on, okay? A third area, before I go into blockchain, and I have very little time now, but I wanted to get these points across. So we built a cloud, right? This is sort of our cloud, and we have Hadoop MapReduce based cloud, and then we've got our policy translation policy layer it's a policy-based cloud. And so different organizations, different social media, or people in one social media, it could be Facebook, it could be a social media and agencies, it could be autonomous vehicles. They are all exchanging information with each other, and they are exchanging information through the cloud. So everybody is putting their data and their policies in their cloud, and information is shared between different organizations, could be, say, trucks, and it could be, say, cars and autonomous vehicles. This could be, say, roadworks and cameras and whatever. They are all talking to each other, and they are all communicating through the cloud. So you put the policies and data in the cloud, and then all the collection, sharing, management, and analytics, everything is done according to the policies. But this is now based in the cloud. So this is something that we've developed actually some of the things is already completed. This part we've done quite well. We have got a policy-aware, secure, assured information sharing example. Okay, so these are sort of the motivation for the next several charts. So now we come to blockchain, right? You may think that, okay, so I've been talking about data science, Internet of Transportation, secure machine learning, and then sharing data in the cloud. What does it all have to do with blockchain? So now, what is blockchain? NIST has defined blockchains to be tamper evident, tamper resistant digital ledgers. It's sort of a distributed ledger implemented in a distributed fashion, without any central control. All right, so that is a distributed ledger that provides secure transmission of data, right? It could be a bank, a company, a government, whatever. Blockchain technologies provide a platform for secure transfer of the data. It's a collection of blocks. And so you go from block to block to block to block to transfer the data. Think of it that way. At the heart of blockchain is cryptography, because secure transfer, because when you do wire transfers, whether you want to do whatever secure transactions, financial transactions, it'll be really great to have security, right? So at the heart of blockchain is crypto that ensures the data being transferred is not tampered with, provides authenticity and integrity. You cannot use blockchain and later say, oh, no, I didn't do something. I didn't withdraw my cash. No, you cannot, right? You can get away when you're not in a blockchain environment, but it provides guarantees, right, authenticity and integrity. Transactions in the blockchain are simply a transfer of assets like data, and the assets are essentially data that may represent financial information, healthcare, or even corporate. So data is very precious. So essentially you are thinking about data being gold and securing the data. One of the most popular applications of blockchain, of course, is Bitcoin. That's a cryptocurrency, right? That's a financial transactions. Transfers of Bitcoins between different individuals are executed through blockchain. So I want to give you some data, but instead of sending money and cash and so on, giving you cash, I send it through Bitcoins. Another example is Ethereum. It is stated, and my paper has references, Ethereum has been created to implement not only these transactions, but contracts. So instead of just transactions, there are also contracts which contain transactions with conditions. I can do this provided you cannot do that. Remember all the policies I mentioned earlier? Those could be sort of like contracts implemented in this environment. Such contracts are called smart contracts. Because why smart? Because it's also providing security, because blockchain is the underlying technology, and I have applications in areas such as IoT, where billions of devices have to work together and create smart contracts for exchanging data and executing processes. So essentially, what are blockchains? They deal with transactions, and transactions involve data. Massive amounts of data have to be, remember, in our area, in our application, we believe in big data, right? Our focus, massive amounts of data collected, processed, analyzed, shared in various transactions. Blockchain could provide a secure execution platform, right? Wouldn't it be great for all what we are doing if we have a secure execution platform? So what are blockchain technologies? It essentially consists of a collection of blocks. So as I said, they're block, 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 and they're all linked. So from data is going from block to block to block to block. Every time it's verified and it's authenticated and so on. So we are chain. A block is essentially a file that contains data pertaining to a transaction. The data from one block may be transferred to multiple blocks. So one block, it can go to multiple blocks. Furthermore, a block can also receive data from multiple blocks. Things can come in. The data in each block is permanent. It's immutable, right? You cannot change. Blocks can be added to the blockchain as transaction progresses. More and more blocks can be added. Very flexible. Each transaction has to be verified. However, unlike a non-blockchain applications where transactions are usually verified by a central authority, but blockchain-based transaction, it's distributed collection of processes. So there's no central person who can cheat, right? Because everybody is monitoring what the other person is doing. An important component of blockchain is, of course, in the cryptographic hash functions. It's a form of message digest where checksums are computed based on the data contents. You look at the contents, you compute a checksum. This is one of the key components that provide security, like confidentiality, integrity, authentication for blockchains. Another major component of blockchain is the notion of transaction, right? Which is a means of interaction between two parties, right? We can exchange goods and we can, do all kinds of stuff, whether we want to use PayPal or whatever, and we've got to pay, but we pay instead of in cash or credit card in cryptocurrencies. Or So also it is through transactions that cryptocurrencies are passed through the users of the blockchain. But transactions are executed in a distributed fashion, and therefore the architecture to support the blockchain is a distributed ledger. Okay, so this gives you a very brief snapshot of blockchain. Now, how do we apply blockchain for data science? Okay, securing the data collection. Remember what we are saying: data collection, data processing, policy aware, data management, data analytics, and data sharing via blockchain is being examined. And there's an article I refer in the paper. It says, since the data that is provided at blockchain ensures of data integrity, yes, it does enhance big data. Data scientists, they are saying, are now relying on blockchain to authenticate and track data at every point on a chain. It's immutable security, right? Once it's done, that's it, is one of the main drivers for its adoption. This decentralized ledger protects data through multiple signatures, thus preventing data leaks and hacks. Blockchain is becoming key to maintaining trust, improving data quality, and securing the sharing of data. With the decentralized nature of blockchain, trust can be ensured by a collection of processes. It's a peer-to-peer. Similarly, for data sharing, blockchain technologies enable multiple parties to access and share the data. Securely, blockchain also enables verification of the integrity of the data at every point of the transaction. Other efforts of blockchain for data science include applications in big data analytics to analyze private data. This approach could be based on the notion called hyperledger, right, in the blockchain terminology. Distributed ledger, you can have hyperledger fabric blockchain, right? That's a particular technology that you can use for the analytics purposes. We argue that blockchain-based cryptocurrencies have the entire transaction graph accessible to the public. Everybody can see. All the transactions can be downloaded, analyzed. We then investigate whether the transaction graphs in blockchain impact the price of the underlying cryptocurrency. This is some of the work that we presented, I'm saying, in the International Conference on IEEE Conference on Data Mining. So essentially what I'm saying is blockchain can be applied to every step in the data lifecycle framework. And remember all the policies that we are saying, those policies could be implemented as these smart contracts with applications such as Ethereum, right? So this is really the beauty of blockchain. And then very quickly, blockchain for cybersecurity. And I've mentioned some of this stuff before in the previous charts. Again, we have said centralized storage, right? Single point of failure or single point of entry. We don't want that, right? So we want distributed capability for blockchains. Data is distributed across devices. And we have a distributed ledger-based architecture for blockchain, and it facilitates distributed data storage. And I mentioned about cryptographic checksums used to ensure security, and the key can be revoked anytime. And this way one can enforce dynamic security, right? Another application of blockchain is in providing IoT security. Billions of devices are connected. Such a system facilitates distributed processing, and we can also ensure secure communication. And one of the beauty here is that all of the contracts between the devices can be written also with smart contracts. A third area of cybersecurity application is DNS, domain name system. DNS systems are usually centralized, and hackers can really, create havoc. But due to the distributed nature of blockchain, hackers will find it more difficult to find the single point of entry. Finally, a lot of messaging systems use end-to-end encryption. However, more recently, these systems are beginning to use blockchain. Again, the distributed processing capabilities provided by blockchains enables a uniform way of communicating. So again, distributed nature, distributed ledger, and crypto encryption. This is the key behind blockchain. Okay, now let's go back to our examples. Okay, directions. How can blockchain be applied to our privacy-aware, policy-based data collection, management, storage, and so on? All of this data is coming in, and policies are guiding data collection, data storage, data analytics. All of that process can be implemented as a collection of blocks. With blockchain technology, we have data collection. They are all collecting, and it's being encrypted, and so on. Similarly for storage, similarly for analytics, similarly for data sharing, right? All of the contracts we can use Ethereum, right? Smart contracts for all the policies. So blockchain, I believe, is a very good application in this privacy-aware data analytics. And because of the immutability property, it can guarantee security, right? So we can encrypted backup storage, anonymized data, and again, a blockchain-based, privacy-aware, policy-based quantified self-manager running on the device. Next, we talked about, right, Internet of Transportation. All these cars are talking to each other, trains with cars and trucks and roadworks with cars. All of them are talking. IoT. And remember, IoT, billions of devices. Between any communication between two devices, there could be some contracts, smart contracts written. And all of the data transfer between these cars and the vehicles, it's a distributed fashion. We can do this as a collection of blocks where data is transferred, and at every point there is verification, right? Security is provided. And again, in a distributed fashion, you can implement this Internet of Transportation for autonomous vehicles. So again, the question is, how is the blockchain can be applied to this particular picture, integrating blockchain with data science, AI, security, and the Internet of Transportation systems? That's where I believe the future is. And the last chart I have is the direction, blockchain-based. Remember, the information sharing in an organization, right? Or within, across organizations. So you have a distributed organization. It would be 2, 3, 4, 5, 6 organizations working, sharing data in the cloud. And you can implement this sharing data as a collection of blocks. When data is going from one person to another person, maybe some of these techniques that we have implemented may be redundant, because through blockchain, it can grow from block 1 to block 2 to block 3, block 4. Every time it's tested, verified, and the policies are ensured through the smart contracts, and it goes through to another party. So information sharing between a collection and distributed processes, I believe that's a great example that we can use, with blockchain. So, and finally, where do we want to go? Of course, I talked about data science and cybersecurity privacy. Then I talked a little bit about blockchain. Then I talked about how blockchain could be applied to some of our applications. And finally, where do we want to go? So next step is to examine various aspects of data science, including our work, privacy-aware, policy-based data lifecycle or data management, Internet of Transportation, and explore how blockchain can be securely applied for various distributed transactions. Another thing I want to add also is data sharing. What about blockchain-based data science for insider threat detection and adversarial machine learning? That is something, so data sharing comes in here too, okay? Right, so I said data science activities, which also includes data. But then I also talked about data science for cybersecurity and securing the machine learning techniques. So that's something we are just beginning to explore. How can we apply data science, right, for cybersecurity? We know that, but how can we bring in blockchain? And remember, I talked about adversarial machine learning. How can blockchain play a role, right? Can blockchain ensure that the security of the machine learning algorithms are guaranteed, because we'll have a distributed processing of the machine learning? Those are things that we are beginning to explore. Another thing is smart contracts. Remember, I mentioned Ethereum in supply chains, including data supply chains. So whenever you have the supply chain systems and data is being created from a number of other data sources, and we build a data product, or you build any other even mechanical product from different parts, whatever. So contracts have to be written between different parties, and then blockchain could have a big use there in supply chain. Blockchain applications in cybersecurity need to be explored further, including what about things like ransomware? And as I said, adversarial machine learning, right? Can blockchain will help us in the ransomware problem? That's something I really haven't looked at. Actually, it's machine learning. Okay, spelling error, sorry. So we believe that blockchain is the glue that integrates data science and cybersecurity for a number of applications, especially if these applications are distributed in nature, right? We have these smart contracts, and we have it's a distributed ledger-based execution, right? So I think this is really the future, I would say, blockchain, because we know that data science, machine learning is also the future, AI, right? Everybody's talking about AI. And cybersecurity, of course, is kind of a disruptor in the sense that cybersecurity attacks will cause really crazy things. All the great AI that you can have in machine learning and data science, if they are attacked, they are of no use. Hopefully, blockchain is the technology that will prevent these AI, data science, machine learning to work in a secure fashion. That is what I want to stress. And I would like to thank all my colleagues who have contributed, and Ms. Rhonda Walls, who is our project coordinator. So this ends my presentation. And sorry, I got to. So I'm going to stop sharing. And so it's just about half an hour. I don't know how much time we will have for questions, because we took exactly half an hour. But again, I will be there live to give this presentation. So I always do tapes just in case that there's a technology glitch, so that the conference organizers can play this tape. So I will see you, I believe, 2 days from today. Today is October 20th. I'm going to see you October 22nd virtually, and I'll be giving this presentation, and also I'll be happy to answer any questions. Thank you very much again for inviting me to give this presentation. Because I was allocated half an hour, I had to rush many topics. If I had had more time, I would have gone into some more detail. But I just want to leave you with this one message, that I believe that blockchain is going to be the solution for secure transaction execution, secure execution of processes, collaborative learning, all of the stuff, all of the tasks that can be worked out in a distributed fashion. We can use blockchain to address, to solve the problem. And it will also address many of the security challenges that we have. Again, thank you very much, and see you in 2 days. Bye. And I'm going to stop the recording.